The universe is too vast, too old for us to be alone. Yet the silence is deafening. Where is everyone? Are we the first, the last? Or are we being hidden from something? Something we're not meant to find. Unexplained signals. UFOs defying physics. Whispers of contact. The truth is out there, and it's either terrifying or worse. We're not prepared for the answer. Are we alone, or are we being watched? Imagine standing on a beach, warm wind on your face, sand between your toes. Now pick up a single grain of that sand, just one. That tiny grain is Earth. The beach, that is the universe, or maybe the part of it. That is how small we are. Earth feels big when you look out your window or fly across oceans. But in space terms, it is almost nothing. A dot, a flicker in a vast, endless dark. Let's start close to home. Our solar system is a tiny neighborhood. It holds our sun, 8 planets, a bunch of moons, and countless comets and asteroids. If you could drive across it at the speed of light, it would still take hours to get from one end to the other. And that's just our little backyard. Now zoom out. We live in a galaxy called the Milky Way. Imagine a city of stars. That's what a galaxy is. A single galaxy can hold over 100 billion stars. That's a 1 with 11 zeros. Our sun is just one of those stars. Many of those stars are like our sun. And many of those stars have planets around them. Big planets, small planets, hot ones, cold ones. Some might even be like Earth. Scientists estimate there are more than 2 trillion galaxies we can see. That's trillion with a T. If each galaxy has 100 billion stars, and each of those stars might have a few planets, then the number of possible planets is hard to even imagine. We are talking about numbers too big for our minds to hold. Try this. Let's say Earth is a grain of sand again. If you had a handful of sand, maybe that's the solar system. A bucket of sand might be the Milky Way. The entire Earth's beaches? That might be closer to what the universe looks like. Every grain of sand in that giant pile is a planet. Some could have oceans, some might have skies, some might have life. And here we are, one small grain. The size of the universe matters because it tells us something important. If the universe is this big, with this many planets, then the chances of life somewhere else go way up. It's like buying a ticket in a lottery. If there are 1 trillion lottery tickets and life is the prize, then somewhere someone probably holds a winning ticket. Even if life is very rare, it does not need to be common to be out there. Let's say life begins on just 1 in a billion planets. That still means there could be millions of living worlds. Not just 1 or 2, not just a maybe, but millions. This is what we call the cosmic lottery. The odds of winning are tiny, but with enough tickets, a win is almost certain. Time is another big reason why the search for life makes sense. The universe is very old, about 13.8 billion years. Earth is younger. It formed about 4.5 billion years ago. Life here began fairly early in Earth's history. Simple life, like tiny bacteria, has been around for most of Earth's lifetime. Complex life, like plants and animals, came later. And humans? We've only been here for a blink, just a few 100,000 years. Now think about all those other planets. Many of them are older than Earth. Some formed billions of years before our planet did. That means life could have had a head start. There could be planets out there where life began billions of years before it began here. What could life become with that much time? What might it have built? What might it know? We look up at the stars and wonder if someone else is looking back. This is why the size and age of the universe are not just facts to memorize. They are the reason we keep searching. The more we learn about space, the less alone we seem. Every time we build a better telescope, we find more stars, more galaxies, more planets. We used to think Earth was the center of everything. Then we learned we orbit the sun. Then we learned the sun is just another star in the Milky Way. Then we learned the Milky Way is just one of billions of galaxies. At each step we became smaller, but the universe became bigger, and that gave us hope, because a big old universe is the perfect place for life to exist. Astronomers are not dreamers. They are careful. They rely on math and machines. They test, they double-check. But still, many of them believe we are not alone, not because of wild stories or science fiction, but because of scale, because of size, because of time. So when we ask, are we alone, maybe we are asking the wrong question. With all this space, all these stars, all these planets, and all this time, The real question becomes something else. How many neighbors do we have? If you want to know what makes a planet perfect for life, start with a glass of water. Scientists believe that for life as we know it to exist, liquid water is key. Life on Earth needs it. Every cell in your body depends on it. Without water, nothing on Earth would be alive. So, when scientists search for life beyond Earth, water is always at the top of the list. But water alone is not enough. The planet has to sit in the right place. Not too close to its star, not too far away, just the right distance. This special zone is often called the Goldilocks zone. The name comes from the old story about the girl who liked things not too hot and not too cold, but just right. Earth sits in the perfect spot in our solar system. It is warm enough to keep water from freezing all the time. It is cool enough to keep water from boiling away. This balance is rare. Venus is too close to the sun and too hot. Mars is farther out and too cold. Earth is in the sweet spot, but every star is different. Bigger stars are hotter. Their Goldilocks zones are farther out. Smaller stars are cooler. Their zones are closer in. So when we search for planets that might hold life, we look for ones that orbit inside these special zones. Water is the first ingredient. Then come the building blocks. You need the right chemicals. Carbon is one of them. So is oxygen, also nitrogen. These are common elements. They are found all over the universe. They are the stuff of stars and dust and planets. On Earth, they form proteins, DNA, and cells. Without them, there would be no plants, no animals, no people. Next, life needs energy, something to power the system. On Earth, most life gets energy from sunlight. Plants use it to grow. Animals eat the plants. But not all life depends on light. Some life forms deep in the ocean use heat from the planet's core. Others feed on chemicals in dark caves. So when we search for life elsewhere, we also look for planets with energy sources, sunlight, heat, or even chemical reactions. Then comes protection. A good planet needs a shield, a layer of gas that wraps around it. This is called an atmosphere. Earth's atmosphere keeps us warm. It gives us air to breathe, and most importantly, it blocks harmful rays from the sun. Without it, we would be burned or frozen or poisoned. So a life-friendly planet needs some kind of barrier, something to hold in warmth and keep out danger. Finally, life needs stability, a place that does not change too fast, a place without too many disasters. If the temperature swings wildly, if the planet gets hit by asteroids too often, if volcanoes and quakes tear the land apart every day, then life has a hard time starting or surviving. Earth has had its share of changes, but overall it has been stable for billions of years. That has given life time to grow and evolve. These are the ingredients: water, chemicals, energy, protection, stability. But here is where things get interesting. Earth is not the only place that might have them. Some of the most promising places for life are not even planets. They are moons. One of them is Europa, a small moon that orbits Jupiter. It is covered in ice, but scientists believe there is a deep ocean hidden under that ice. That ocean may be kept warm by the pull of Jupiter's gravity. And where there is warm water, there could be life. Another moon is Enceladus, which orbits Saturn. It also has an icy shell and may have a liquid ocean beneath. In 2005, a spacecraft named Cassini flew past it and saw geysers shooting water into space. That water held salt and simple organic molecules. That was a huge clue. It meant something was going on beneath the surface. Something active. Maybe even something alive. Then there is Titan, Saturn's largest moon. Titan is different. It is cold, very cold, but it has lakes and rivers, not of water, of methane and ethane. Strange chemicals that are liquid in the freezing temperatures of Titan. It has a thick atmosphere. It has complex chemistry. It is not like Earth at all. But it might still be home to some kind of alien life. Scientists are now asking a big question. Could life exist in ways we have never imagined? Could there be creatures that do not need water? Could life form using different chemistry? We are just starting to ask these questions, and already Earth is giving us clues. On Earth, life is everywhere. In deserts, in ice, at the bottom of the ocean, in boiling acid inside rocks. Scientists have found tiny life forms called microbes living in places once thought impossible. Some live deep underground. Some live in lakes filled with salt or poison. Some survive heat and pressure that would kill humans in seconds. These discoveries have changed everything. They tell us that life is tough. Life adapts. Life finds a way. That is why scientists are searching so many places. They are looking for rocky planets like Earth, planets that orbit stars like our Sun, but they are also looking at red dwarf stars. These stars are smaller and cooler. They live much longer. They might give life more time to grow. Planets around red dwarfs may be close to their star. That means they could be locked with one side always facing the light and the other in darkness. But even then, life might survive in the twilight zone in between. Astronomers use powerful tools to find these planets. They look for tiny dips in starlight when a planet passes in front of its star. They measure how the star moves when pulled by a planet's gravity. They study the light from these planets to see what gases are in the air. Sometimes a planet looks perfect from far away. It is the right size. It is in the right place. But when we study it more, it turns out to be too hot or too dry, or has no atmosphere. That is part of the challenge. These worlds are so far away. The closest star to us is still over 4 light years away. That is over 20 trillion miles. We cannot visit them. We cannot land on them. All we have is light, and light is what we study. But each year the tools get better. Telescopes are sharper, computers are faster, and we are finding more and more planets. Over 5,000 have been confirmed so far, and many more are waiting to be studied. Among them are some that might be just right. Maybe not exactly like Earth, but close enough to imagine standing there, looking up, wondering if something is looking back. So now we know the recipe. We know what to search for. We are looking for water, for the right chemicals, for warmth, for air, for calm. And we are looking everywhere. Planets, moons, stars big and small. Because life might not just be out there, it might be everywhere. The next step is to explore the worlds we have already found. Before 1995, if you had asked a scientist how many planets there were outside our solar system, they would have shrugged. They would have told you it was possible there were planets around other stars. But no one had ever seen one. No one had measured one. No one could prove they were really out there. For all we knew, our solar system might have been the only one. Then came a discovery that changed everything. It happened in October 1995. 2 scientists, Michel Mayor and Didier Queloz, were studying a star called 51 Pegasi. They were not looking at the star itself, but at the way it moved. It was wobbling just slightly as if something were pulling on it. That something turned out to be a planet. This planet was nothing like Earth. It was huge and hot and raced around its star in just 4 days. But it was the first confirmed planet beyond our solar system. A world circling a distant sun. A new kind of planet. An exoplanet. Since that first one, the hunt has exploded. Thousands have been found. Some are rocky like Earth. Some are gas giants like Jupiter. Some are smaller than Mercury. Others are many times bigger than our whole planet. And yet, we have never seen most of them. That might sound strange. How can we discover planets we cannot see? The truth is, planets are hard to spot. Stars shine brightly. Planets reflect light, but not much. From far away, the light of a star hides the tiny dot of a planet beside it. So scientists use tricks to find them. One method is called the transit method. Imagine watching a bug crawl across a flashlight beam. The light dims just a little as the bug passes. Now imagine a planet passing in front of its star. The light from that star dips slightly. If the dip repeats on a regular schedule, that is a clue a planet is circling it. Another method watches for wobbles. As a planet orbits its star, it tugs on it. Not much, but enough to shift the star's position a tiny bit. Sensitive instruments can detect that movement. If the tug keeps happening in a regular pattern, it may be caused by a planet. These tools have opened a door to a hidden universe. A universe full of strange and beautiful worlds. Let's take a tour of some of the most exciting ones. Start with a planet called K218b. This world is 8.5 times heavier than Earth. It orbits a small star about 120 light-years away. It is far from us, but close enough for the James Webb Space Telescope to study its atmosphere. Webb found signs of carbon dioxide, even methane. Both of these gases can be linked to life. No one is claiming life has been found there, but the ingredients, they might be in place. Now picture a world called LHS 1140b. Some call it the eyeball planet. It is tidally locked. One side always faces its star. The other side is always dark. But in between lies a zone that might be just right. That narrow ring could be warm enough for water to flow. That is why scientists are watching it closely. This world is about 50 light years away. In cosmic terms, it is in our neighborhood. Then there is Kepler 452b. Some people call it Earth's cousin. It is bigger than Earth, but circles a star much like our sun. It orbits at a distance where water could exist. It takes almost the same time to complete one trip around its star as Earth does. It is what scientists call a potentially habitable world. And then we come to TRAPPIST-1. This is not one planet, but a system of 7. 7 Earth-sized planets orbiting one small star. Some of them are in the habitable zone. That means they could have water, maybe even oceans. It is one of the most exciting discoveries in the history of planet hunting. The closest of all might be Proxima Centauri b, just 4 light years away. It orbits the star nearest to our sun. It may have the right temperature. It may be rocky. It may have water. We do not know yet. But if we ever send a spacecraft to another star, this could be the first place we go. Not all exoplanets are familiar. Some are wild and strange. There are planets made mostly of carbon. Under the right pressure, carbon becomes diamond. That means somewhere out there could be a world covered in diamond mountains. Others have skies that rain metal. On a planet called HD 189733b, winds race at thousands of miles an hour. The atmosphere may contain particles of glass or iron. When it rains, it could rain melted metal sideways. Some planets orbit not one star, but 2 or 3. That means they would see multiple suns in their sky. Imagine sunsets that come in pairs, or days lit by the glow of several stars. There are super-Earths. These are planets bigger than Earth, but smaller than Neptune. Some might have thick atmospheres. Others could be dry and rocky. Each is its own mystery. Mini Neptunes are smaller versions of our giant gas planets. They might have thick gas blankets or even liquid oceans hidden beneath. Some could be in the right spot for life. To study all of this, we have a new tool, the James Webb Space Telescope. Webb is unlike anything before it. It does not just look at light. It studies the fingerprints left in light. When a planet passes in front of its star, some starlight passes through its atmosphere. That light can be split into colors. Each gas in the air leaves a mark. This tells scientists what the air is made of. Webb can see things Hubble never could. It is already making discoveries. Water vapor on distant planets, carbon molecules in alien skies, patterns that hint at clouds or storms or chemistry we do not fully understand. This telescope may one day spot the signs of life. Not life itself, but what life leaves behind. Oxygen, methane, certain patterns that do not happen without living things. So far, more than 5,000 exoplanets have been confirmed. Thousands more are waiting for study. These are just the ones we have found with our current tools. There are likely billions more in our galaxy alone. Every time we look deeper, we find more. The search is growing faster. New telescopes are being built. New missions are planned. Some will search for planets. Others will look for biosignatures. Some may even try to take pictures of distant worlds. In this vast ocean of stars, we are mapping the islands. Each planet is a possible home, a possible story, a place where life may already exist, or may one day begin. We once thought Earth was unique. Now we know it is not. We once thought we were alone. Now we are not so sure. The planets are there. They are real. Some are hot, some are cold, some are wild, some are calm, some may be alive. We have found the worlds, but how do we know if anything is actually living on them? Picture this. You are a detective, but not in a city, not even on Earth. You are hunting for clues scattered across the universe. You are looking for something invisible, something far away, something that might mean life. You cannot see it directly. You cannot touch it, but you might find its fingerprints. This is what scientists do when they search for signs of life on other planets. They are like detectives reading messages written in light. They're looking for what are called biosignatures. These are hints that life has changed something in the air or on the surface of a planet. Not proof, but signs. Whispers. A gentle nudge that says something might be alive out there. Start with the air. On Earth, the air is full of oxygen. That sounds normal to us. But it is actually strange. Oxygen is reactive. It loves to bond with other things. If nothing kept making it, it would disappear. The only reason our air stays full of oxygen is because plants and algae keep pumping it out. They breathe in carbon dioxide and let out oxygen. Without life, the oxygen would vanish. So if scientists see oxygen in the atmosphere of another planet, it makes them pay attention. It could be a sign that something is breathing and growing. But oxygen alone is not enough. Other things can make oxygen too. Light from a star can break apart water and leave oxygen behind. Certain minerals can react and do the same. That is why scientists look for pairs of gases, like oxygen and methane. Methane is another gas that should not last long. On Earth, cows make methane. So do microbes. When you see both oxygen and methane together, it usually means something is alive. These gases do not like each other. They react and destroy each other. If they both exist in the same air, something must be making them fresh all the time. Another clue is water vapor. Liquid water is key to life as we know it, but even vapor can tell us something. If a planet has the right amount of water in its atmosphere, it might have oceans or lakes. It might be warm enough, wet enough, friendly enough. Even seasons can give clues. On Earth, plant life changes with the seasons. Trees bloom and die back. Grasses grow and fade. These changes affect the air. Carbon dioxide levels shift. If we see similar seasonal patterns on another planet, it could mean something is growing there too. And then, there are the stranger ideas. What if we could detect pollution? On Earth, we create gases that would never exist naturally. Things like nitrogen dioxide from burning fossil fuels, or chlorofluorocarbons used in sprays and coolants. If we ever found these on another world, we might be seeing signs of industry, signs of machines, maybe even a civilization. This is where science turns into detective work. The main tool scientists use is called spectroscopy. It sounds complex, but the idea is simple. Every gas affects light in its own way. Think of it like a barcode. When light passes through an atmosphere, certain colors are absorbed. Those gaps in the light tell scientists what gases are present. This is how we know the air on Saturn's moon Titan is rich in methane. It is how we found water vapor on a planet more than 100 light-years away. Spectroscopy is reading the rainbow of light. It turns space telescopes into long-distance sniffers. They cannot smell, but they can see what is in the air, just by studying the light. The James Webb Space Telescope is especially good at this. It is already finding carbon dioxide and methane on distant worlds. It is looking deeper than ever before. It can see the fingerprints of molecules across space and time. But even with these tools, false alarms are a real problem. Nature can be tricky. Volcanoes can make methane. Certain rocks can release oxygen. Even weather can play tricks. That is why scientists need to be sure. They need to find more than one clue, more than one piece of evidence. They need a pattern that life would leave, not a fluke that geology could fake. That is also why they use more than one telescope. One telescope might see water vapor, another might confirm oxygen, another might spot methane. Together, they paint a fuller picture. Scientists also use computers to study the data. These programs can find tiny signals buried in noise. They can model how an atmosphere might behave. They can tell us if a signal makes sense, or if it is probably just background static. But the clues are not always in the air. Some scientists dream of spotting lights on the night side of a planet, maybe streetlights or glowing cities. It is a long shot, but it is not impossible. Others wonder if we could spot giant farming areas or massive changes to a landscape, like canals or shapes too precise to be natural. Some even think we might find trash, industrial waste in the air, leftover chemicals that only machines can make. These are called technosignatures, signs of technology, signs of not just life, but intelligence. We have already had a few moments that made people stop and wonder, In 2020, scientists announced they had found a gas called phosphine in the clouds of Venus. On Earth, phosphine is made by life. The discovery caused a stir. Some thought it might be a sign of floating microbes in the Venus atmosphere. Later studies questioned the result. The signal might have come from something else, or it might not have been real at all. But it showed how serious scientists are about these searches. Another big moment came when water vapor was found in the air around a distant planet in the habitable zone. That was a huge step. It meant the planet might have clouds, maybe rain, maybe oceans. Recently, scientists even found silicon monoxide in extreme planetary atmospheres. This gas forms at very high temperatures. Its presence helps us understand how some strange worlds evolve. It does not point to life, but it helps us narrow the search. With every discovery, the search becomes more focused, more refined. We are getting better at telling which planets are too hot, which are too cold, which are dry, which might be wet, which ones look dead, which might be alive. It is slow work, but it is careful work, and it is worth it. Because we are not just looking for a signal. We are not just reading light. We are asking a question as old as time. Are we alone? So far, we have found no direct proof of life, but we are closer than ever. We know what to look for. We know where to look. And now, with better tools and sharper minds, we might soon have an answer. But there is one more twist in this story. While we search for signs of life out there, what if someone is trying to contact us? What if right now a signal is flying through space headed for Earth? What if the clues are not just out there waiting to be found, but on their way to our doorstep? For as long as people have looked up at the night sky, they have wondered the same thing. Are we alone? The stars have always sparked questions. Ancient cultures turned them into stories and gods. Sailors used them to guide their way. Poets wrote about them. Scientists studied them. But in all that time, one question never faded. Is someone else out there? Someone intelligent? Someone watching the same stars? Maybe even trying to reach us? That question became more than a dream in the mid-20th century. It became a science. This is where the story of SETI begins. SETI means Search for Extraterrestrial Intelligence. It is a quiet kind of science. It does not send rockets or dig through dirt. It listens carefully, constantly, patiently, hoping for a signal from far away. The first serious attempt came in 1960. An astronomer named Frank Drake pointed a radio telescope at two stars similar to our sun. He was listening for signals that did not come from nature. He used radio waves because they travel far. They pass through space with very little interference. They are used on Earth for all kinds of communication, so it made sense to think aliens might use them too. Drake heard nothing that time, but he started something that would last for decades. Over the years, more scientists joined the search. They built better telescopes, wrote smarter computer programs, shared data, and kept listening. Then in 1977, something strange happened. A radio telescope in Ohio picked up a signal. It lasted just over a minute. It was strong and clean and came from deep space. A researcher wrote one word next to the printout. Wow. To this day, no one knows what the wow signal was. It never repeated. It could have been a natural event or a glitch, or it could have been something more. Something trying to say hello. That mystery keeps scientists searching. Today, the effort is bigger and smarter than ever. In Northern California, the SETI Institute runs the Allen Telescope Array. Dozens of dishes spread across the landscape. Working together, they scan the sky day and night. They listen to stars. They listen to galaxies. They listen to places where we have found planets. Each one is a possible home. In 2015, a new project began. It is called Breakthrough Listen. It is backed by a private donor and costs $100 million over 10 years. Its goal is simple. Search 1 million stars. Scan the entire plane of the Milky Way. Listen to 100 nearby galaxies. It is the most ambitious listening program ever launched. The telescopes used in this project are powerful. They can detect tiny signals, even from distant places. But the real power lies in the computers. These machines sift through millions of signals. They throw out noise. Look for patterns. Try to spot something that stands out. So, what are scientists looking for exactly? They are not listening for voices, not words, not music. They are looking for signs of purpose. One type of signal is called a narrowband signal. Natural signals, like those from stars or planets, tend to be broad and noisy, but a focused, narrow signal, especially one that repeats or shows structure, is something nature does not usually make. They are also looking for patterns, pulses that repeat at steady intervals, changes that follow mathematical rules, especially prime numbers. A prime number is only divisible by 1 in itself. It is something nature rarely produces, but something intelligent beings might use to get attention. Another clue would be a signal that comes from a specific star system, maybe one where we know planets exist, maybe one where a planet looks like Earth. But even with the best tools, this is hard work. The universe is huge, and we do not know exactly where to look, or what kind of signal to expect, or even what frequency aliens might use. This is called the haystack problem. Imagine looking for one grain of rice in an ocean of sand. That is what SETI faces every day. And what if aliens are not using radio at all? Some scientists think they might use lasers, bright, sharp beams of light. These would stand out in space, a quick flash in the dark, a cosmic flashlight blinking a message. This is called optical SETI. It is still new, but it offers another way to look. Others look for signs of alien technology. These are called technosignatures. They include things like strange heat patterns from a planet, or odd chemicals in an atmosphere, even massive structures built in space. One idea is a Dyson sphere, a huge structure that wraps around a star to collect its energy. If something like that exists, it would block some of the star's light. We might notice the change. Another idea is artificial structures, something big, something geometric, something nature could not make. All these things are hard to spot, but not impossible. So what happens if we find something? The scientific world has a plan. There are international rules for reporting alien signals. First, the data must be checked, confirmed by other telescopes, verified by different teams. Only then is it shared with the world. The reason is simple. False alarms happen. One famous case turned out to be a microwave oven in the observatory break room. The signal was not from space, it was someone heating their lunch. But if the signal is real, everything changes. People around the world would react, some with joy, some with fear. News would spread fast, questions would rise even faster. Are they friendly? How far away are they? Should we answer? That last question is a big one. Some scientists say yes, others say no. What if we give away our location to a civilization more advanced than us? What if they are not peaceful? This debate has no answer yet. For now, we keep listening, and we are better at it than ever. We listen across the radio spectrum. We look for light signals. We search for alien technology. We study planets for signs of life. The sky is not silent. It is full of signals. From stars, from galaxies, from human-made satellites, from Earth itself. But hidden in all that noise, there could be a message. One that says we are not alone. We have not found it yet, but the search goes on. And here is something to think about. While we are listening for aliens to call us, what if we have been looking in the wrong direction? What if the signs are already here? What if the closest signs of life are not across the galaxy, but right next door? What if the real question is not when will they contact us, but why have we not seen them in our own backyard? For most of human history, we looked to the stars and asked if anyone else was out there. We imagined alien civilizations living on planets far beyond our own. But over the past few decades, something surprising has happened. Scientists have started looking closer to home, and what they are finding may change everything we thought we knew about life in the universe. Not long ago, most experts believed life was rare, maybe even unique to Earth. But discoveries in the last 30 years have turned that idea on its head. It turns out that many places in our own solar system may have the right conditions for life. Not big creatures, not flying saucers, but simple life, microbes, tiny forms that could survive in dark, cold, or strange places. The kind of life that doesn't need sunlight or fresh air, just the right mix of water, chemistry, and time. Let's start with the planet next door. Mars has been a mystery for centuries. Early astronomers thought they saw canals. Later missions showed a dry, dusty world. But as our tools got better, a new picture came into view. Mars was not always dry. Billions of years ago it had rivers, lakes, maybe even oceans. We see the evidence in dried-up riverbeds and minerals that only form in water. Today there is no flowing water on the surface, but water still exists underground. Ice has been found just below the surface. In some places, seasonal changes suggest that salty liquid water may still flow now and then. Mars also has a thin atmosphere, and here's where things get interesting. Scientists have detected methane in the air. Methane is a tricky gas. It can come from rocks, but on Earth, a lot of it comes from living things: cows, microbes, wetlands. On Mars, we don't know where it comes from. The fact that it appears and disappears with the seasons is a clue. Something active is going on. It might be geology, or it might be life. Right now, robots like the Perseverance rover are exploring Mars. They are digging, sampling, sniffing the air, looking for the tiniest signs of past or present life. In the near future, we plan to bring samples back to Earth. These samples may hold the answer. But if life exists on Mars, it will likely be small, simple, hidden deep below the surface. It may not be impressive to look at, but it would change everything. Mars is not the only place to look. Farther from the sun, we find a moon called Europa. It orbits Jupiter. On the outside, it looks like a ball of ice. Cracks cover its surface, like lines on old glass. But underneath that ice lies an ocean, a vast, deep ocean. In fact, Europa may have more water than all of Earth's oceans combined. How can that be? How can a moon so far from the sun stay warm enough for liquid water? The answer lies in gravity. As Europa orbits Jupiter, the planet's massive pull stretches and squeezes the moon. This motion creates heat inside, enough to keep the ocean beneath the ice from freezing. But water is just the start. On Earth, some of the most surprising life forms live at the bottom of the ocean. They gather around hydrothermal vents. These are cracks in the sea floor where heat and chemicals pour out. No sunlight reaches them, yet they are full of life. Scientists believe the same kind of vents may exist on Europa. If so, the ocean below could be a home for life. Maybe not life like us, but microbes, or even something more complex. Some researchers think Europa is the best place in the solar system to find life beyond Earth. Then there is Enceladus. This is a small moon of Saturn. It is covered in ice too. For a long time, it seemed quiet and unimportant. But in 2005, the Cassini spacecraft flew past it. What it saw shocked everyone. Jets of water were shooting out from the South Pole. These geysers sprayed icy particles hundreds of kilometers into space. Cassini flew through them. It tasted them, in a way, and it found something incredible. The water contained organic molecules. Simple ones, yes, but the kind that matter for life. Scientists now believe Enceladus has a liquid ocean beneath its icy shell, and that ocean may be heated by the same tidal forces that warm Europa. Enceladus is small, but it has water, heat, and the right chemistry. These are the key ingredients. The fact that we have found them so close to home is a major surprise. Next comes Titan, also a moon of Saturn. Titan is strange. It has a thick atmosphere. It rains. It has rivers, lakes, but not of water. These are made of liquid methane and ethane. Titan is like a frozen version of early Earth. Its surface is cold, too cold for water to flow. But some scientists think that below the surface, there could be another ocean, a hidden sea of water. If that's true, Titan might have two kinds of life, one based on water, deep below, and one based on methane, living in the cold and strange chemistry above. This would be unlike anything we know, a truly alien form of life. It is just an idea for now, but Titan has already proven that nature can surprise us. When we land there again, we may find something completely new, but the list does not stop there. Ganymede and Callisto are two more moons of Jupiter. Both are large, both are icy, and both may hide oceans under their crusts. Pluto, once thought to be a frozen rock, may also have a buried sea. Even Ceres, a dwarf planet in the asteroid belt, has shown signs of water. Bright spots on its surface may be salt deposits left behind by briny water. These worlds are not warm. They are not Earth-like, but they may still hold life. Why does this matter? Because it changes the odds. For a long time, we thought life needed a planet like Earth, with sun and sky and rain. But now we know it might not. Life might exist in the dark, under ice, in strange liquids. It may not need what we need. If that is true, then life could be common, not rare, and that changes everything. So how do we search? Carefully. We do not want to contaminate these worlds. We have to make sure our robots are clean, that they do not carry Earth microbes with them. If we find life, we want to be sure it is native, not something we brought. Future missions will go to these places. Some will drill through ice. Others will dive into plumes. Some may land and sniff the air. Others may fly or float. The tools are getting better. The questions are getting sharper. And the hope is growing. Because if we find life in our own solar system, it means life is not a miracle. It is part of the universe, a natural outcome of the right conditions. Even the smallest microbe on Mars, even a single strange cell in an alien ocean, that would mean we are not alone, not in this solar system, not in this galaxy, not in this universe, and that would be the biggest discovery in the history of science. So we keep searching. Mars, Europa, Enceladus, Titan, Ganymede, Pluto, Ceres, cold, distant, silent, but maybe not empty. Maybe one day we will dig through the ice and find the first neighbor we never knew we had. The stars shine down on us every night. We know now that each one is a sun. Many have planets. Some of those planets are like Earth, rocky, in the right zone. With the right ingredients, we have found thousands, and that is just in our corner of the galaxy. So why does it still feel so quiet? This is the great mystery, the contradiction that keeps scientists awake at night. It is called the Fermi paradox, named after the physicist Enrico Fermi. One day in 1950, he asked a simple question. If there are so many planets and the universe is so old, then where is everybody? He was not joking. He was serious. Because the numbers suggest something strange. There should be life out there, intelligent life, civilizations that have had millions or even billions of years to grow, maybe even explore or send signals. Yet we hear nothing. We see nothing. The skies are silent. The universe is huge, over 13 billion years old. Our galaxy alone has over 100 billion stars. Many stars have planets. Some of those planets are just the right distance from their suns. They are not too hot, not too cold, just right for water to stay liquid. And where there is water, life may follow. Even if only a tiny number of planets develop life, the numbers add up. Even if only a few of those go on to form intelligent beings, there should still be many advanced civilizations. Enough to notice, enough to be seen or heard. But so far, nothing. That is what makes the Fermi paradox so powerful. The math says yes, but reality says no. That gap between what should be and what is feels deep and hard to explain. There are many ideas about what might be going on. One of them is called the rare Earth hypothesis. This idea says Earth might be truly special. Maybe we had the perfect mix of things: a stable star, a planet just the right size, a magnetic field to protect us, a large moon to steady our orbit, giant planets like Jupiter to shield us from too many impacts, the right chemicals, the right distance, and just enough time. Maybe that mix is rare. Maybe Earth is 1 in a trillion. Another idea is called the Great Filter. It suggests there is something that stops life from becoming advanced, something hard to pass. This filter could be in the past. Maybe life itself is hard to start, or maybe simple life almost never becomes complex. Or maybe intelligence is rare, but the filter could also be ahead of us. Maybe civilizations often destroy themselves through war or by damaging their own planet. Maybe they never make it to the stars. They build machines, then vanish. If that is true, then we might be facing the same test. The filter might be in our future. There is another option. The aliens might be out there, but too far away. Space is vast. Even light takes years to travel between stars. Maybe their signals are still coming. Or maybe they came before we had the tools to listen. Some scientists wonder if we are using the wrong tools. We listen for radio waves, but what if aliens use something else? Lasers, neutrinos, something we have not discovered yet? We might be surrounded by messages we cannot read, or maybe they do not want to be found. Maybe they are quiet on purpose, hiding, watching, waiting. Some call this the zoo hypothesis, the idea that we are like animals in a preserve, being observed but never contacted. And maybe, just maybe, we are not ready. Maybe we do not know what to look for. Maybe we would not even recognize a signal if it came. It is also true that our search has barely begun. We have listened to only a tiny fraction of the sky. We have studied only a handful of planets. Our tools are still young. Our reach is still short. We are just starting to look. Some believe that life is common, but simple life, microbes, bacteria, things that live in oceans or under rocks, life like that might be everywhere. But intelligent life, capable of building cities and sending messages, might be rare. Maybe it needs a long chain of lucky events. Maybe it almost never happens. Even on Earth, intelligence is new. For most of our planet's history, there were no humans. For billions of years, life stayed small. Complex life is a recent thing, civilization even more so, and our technology a blink of an eye. So what does the future hold? The next 20 years may bring answers. New telescopes are coming. They will study the atmospheres of thousands of planets. They will look for gases like oxygen and methane, signs of life. They will search with more detail than ever before. SETI, the search for extraterrestrial intelligence, is expanding. It is using more data, more powerful computers, more of the sky. Every year we get better at spotting signals. New missions are being planned, to Mars, to Europa, to Enceladus. These places may hold simple life. If we find it in our own solar system, it will mean life is not rare. It will mean life begins easily. If the conditions are right, that would be a game changer. And if we find a signal, a message, even just a pattern that cannot be natural, that would change the world. It would prove we are not alone. The impact would be massive for science, for religion, for how we see ourselves. Everything would shift. We would know without doubt that we are part of something bigger, even if the signal came from thousands of light years away, even if we could never talk back. Just knowing would change everything. But the truth is, the search has already taught us so much. It has forced us to understand our own planet, to ask deep questions, to build new tools. It has sparked wonder and invention. Many technologies used in space science have found their way into daily life. Better sensors, better software, better ways to share and store data. And maybe more important than anything else, the search reminds us of who we are. We are a curious species. We look up and wonder. We ask hard questions. We seek connection. We explore. Even without guarantees, we keep trying, because the question matters. Are we alone? And maybe, just maybe, that search is the thing that makes us human. Maybe the act of asking, of hoping, is already part of the answer. So we wait. We listen. We look. Not with fear, but with hope. Because whether we find aliens tomorrow or never find them at all, the search is worth it. It brings us together. It lifts our eyes. It stretches our minds. It reminds us that we live on a pale blue dot, a small world full of life, a place where the universe has grown eyes and brains and hands, a place where something extraordinary has happened. And perhaps, somewhere out there, it has happened again.